Now we're looking at describing the shape of distributions and also re-expressing the data to change the shape of distributions. We've already discussed basically unimodal, bimodal, and uniform. The main point is we were looking at those before with our data distributions. Now we are looking at histograms. And the nice part is it's easier to see things like when there are two peaks. Two peaks means bimodal. This is unimodal because it has one peak. And when it's roughly no peaks, we call that uniform because it's very similar across the distribution. We've already discussed things like symmetry, where if you fold it in half and it looks roughly the same on both sides, then it is roughly symmetric. If you have a tail or outliers to the left, that pulls the mean to the left, and so we would say that's skewed left or negatively skewed. Same thing when you have outliers, we call this a tail that pulls it to the right. Then the mean would be pulled to the right, and we would say our data is a skewed right or positively skewed. The other thing you need to talk about when describing the data, and these are things you might not have seen in the distributions we did before, outliers. So first of all, we did do those with box and whisker plots, so you should always indicate outliers. And you should note gaps. Now, gaps won't be available in box and whisker plots, but they're available in histograms and also in stem and leaf plots. So be prepared to outline, to identify these things in any data distributions you analyze. Now, sometimes you're going to get some data that is really narrow and lots of outliers, so it spreads it out and it makes it very difficult to see the distribution. Sometimes what you can do is apply a function to every single data point to change the shape. In this case, we were looking at compensation for CEOs, and when we took the logarithm of their compensation, we could suddenly see a distribution that was a little easier to analyze. So I've got another example for you here. Well, yeah, and this is what I said, applying a function like square root or logarithm. Now, the good news is you're not expected to do the actual re-expressing of data, but you should be able to determine when it's helpful. So in this example, I have the energy release of earthquakes. So this is the actual energy release. And here I took the log of the energy release. Here I took the square root. And here I squared the energy release. In this instance, it became much worse. So I actually don't want this one on the bottom right. This one is actually pretty useful here, and so is this one. So you're not limited in using only one function or the other. You can look at it multiple ways. One thing you should be careful about is that histograms are only for quantitative data, and you can't get shape, center, and spread from categorical data because that's just, if we did Pepsi and Coca-Cola and did a bar chart for preferences, which one comes first, Pepsi or Coca-Cola? Be careful about the bin width and be sure to identify any gaps you see in